Shanghai Matrix Robotics just showed its third-generation humanoid robot with specifications that sound impossible. This robot claims to have features no other humanoid has demonstrated in real-world conditions. What Matrix 3 promises could change how robots work if the hardware actually delivers. Shanghai Matrix Robotics released a video showcasing Matrix 3, described as the company's next-generation general-purpose humanoid robot. The video demonstrates a significantly redesigned robot compared to previous Matrix models. Matrix 3 features a more compact body structure without the protruding rear section that characterized earlier generations. This design change addresses one of the common aesthetic and practical concerns with humanoid robots. The robot's hands represent the most significant claimed advancement. Matrix 3 reportedly features 27 degrees of freedom in its dexterous hand system. This number exceeds most current humanoid robots. For context, Matrix 1, the company's earlier model, featured 22 degrees of freedom in its 5-fingered hands. The increased DOF suggests potential for more precise manipulation of objects. The hand system uses tendon-driven joints rather than traditional motor in joint designs. Tendon-driven systems route actuators away from the fingers themselves using cables to transmit force. This approach can reduce weight in the hands while maintaining strength. However, tendon systems also introduce complexity in terms of maintenance and control precision. Matrix 3 claims to incorporate 3D soft fabric bionic skin with tactile sensing capability. Tactile sensing allows robots to detect pressure and texture and force when touching objects. This feedback helps robots adjust grip strength and manipulate delicate items without crushing them. The bionic skin claim suggests the surface mimics human skin properties rather than using rigid sensors. Bionic skin technology has been advancing rapidly in robotics research. A recent development from Jixing, China demonstrated MBT skin that can integrate 40 microsensors per fingertip, representing a 20 times density improvement over conventional rigid sensors. Whether Matrix 3 achieves similar sensor density remains unverified. The video highlights zero-shot learning capabilities powered by a neural network. Zero-shot learning means the robot can respond to tasks it has never explicitly trained on by generalizing from existing knowledge. This represents a significant AI capability if functional. Traditional robots require specific programming for each task variation. Zero-shot learning would allow robots to handle novel situations without retraining. Shanghai Matrix Robotics positions Matrix 3 for general-purpose use across multiple environments. The company states the robot targets manufacturing plants and logistics warehouses and retail supermarkets. These represent 3 distinct operational contexts with different requirements. Manufacturing demands precision and repetition. Logistics requires navigation and load handling. Retail involves human interaction and unpredictable environments. Robo Horizon. A robotics industry publication noted that Matrix 3 currently exists as a video demonstration rather than a deployed physical prototype. The publication described the content as CGI, acknowledging impressive specifications while reserving judgment until physical hardware demonstrates the claimed capabilities. This distinction matters because rendering capabilities in video differs significantly from building functional hardware. Matrix 1. The company's previous humanoid robot demonstrated actual capabilities that provide context for Matrix 3 claims. Matrix 1 features 30 active degrees of freedom, excluding hands, and operates for up to 5 hours on a charge and includes 8 onboard RGB cameras. The robot uses an onboard vision language model for visual reasoning and can recognize objects and open doors and navigate unstructured spaces. Matrix Hyperintelligence. The parent company developed a brain-cerebellum limb collaborative operating system for its humanoids. This system addresses coordination between high-level decision-making and fine motion control and physical execution. The goal is enabling robots to see and think and act in integrated fashion rather than processing these functions separately. The Chinese humanoid robotics industry has been scaling rapidly. Multiple companies announced production milestones throughout 2025. UBTech reported manufacturing its 1,000th industrial humanoid and plans to produce 10,000 units in 2026. Agibot claims to have shipped 5,000 humanoid robots in 2025. These numbers indicate a market focused on volume production rather than limited prototypes. China's government has set specific targets for humanoid robot development. The country aims to manufacture 10,000 humanoids in 2025 and establish dominance in the market by 2027. This policy support drives investment and accelerates development timelines. Over 150 humanoid robot companies operate in China, creating intense competition. The hand design in Matrix 3 addresses a critical challenge in humanoid robotics. Human hands can perform thousands of different grips and manipulations. Replicating this versatility mechanically requires both hardware capable of complex movements and software that can control those movements precisely. The 27DOF claim suggests Matrix 3 prioritizes dexterity over simplicity. Tactile sensing integration provides robots with feedback humans take for granted. When picking up an egg versus a rock, humans automatically adjust grip pressure based on tactile information. Robots without tactile sensing must rely on vision and pre-programmed force limits, which works poorly for unknown objects. If Matrix 3's bionic skin functions as claimed, it could handle a wider range of objects safely. The zero-shot learning capability depends on the neural network's training and architecture. Recent advances in vision, language, action models have improved robot learning efficiency. These models learn relationships between visual inputs and language instructions and physical actions. A robot trained on enough diverse tasks can generalize to new situations by recognizing similar patterns. However, zero-shot learning in robotics faces practical limitations. The physical world includes infinite variations. A neural network trained in one environment may fail when confronted with different lighting or object textures or spatial arrangements. True zero-shot capability requires massive training datasets and robust generalization algorithms. Shanghai Matrix Robotics has not disclosed Matrix 3 pricing or production timeline or customer deployments. The video release represents a capability announcement rather than a product launch. The robotics industry frequently sees announcements precede actual hardware availability by months or years. Development timelines often extend as companies encounter engineering challenges not apparent in demonstrations. The compact design without a protruding rear eliminates a common aesthetic issue with humanoid robots. Many robots place batteries or computers or actuators in backpack configurations for weight distribution. This creates an unnatural appearance and affects center of gravity during movement. Matrix 3's redesigned form factor suggests improved internal component integration. That covers what is currently known about Matrix 3 based on available information. The robot represents impressive claimed specifications, but physical demonstration remains pending. If this breakdown helped you understand what Shanghai Matrix Robotics announced and why it matters for the robotics industry, subscribe to AI Tech Academy. We track developments in humanoid robotics and AI as they happen. Drop a comment with your thoughts on advanced bionic skin and zero-shot learning in robots. Thanks for watching, and we'll see you in the next one.